back to my channel, and today what we are going to do is this is generating functions part 2. And if you haven't watched the part 1 video where I have explained the intuition behind generating functions and one real life example of what the generating functions mean in real life. Okay, this is part 2. Here we will discuss of how to think if a sequence is given, how to get the closed form of that sequence, or the what is the generating function of that sequence, how to think about it. Okay, so here this is the sequence: 1 minus 2 3 minus 4 5 minus 6, so on. Which of the functions is the generating function of this sequence? So how to proceed? Always we start with the standard. First I will write the sequence we have to get. That is, always the coefficient represents the sequence, the term of the sequence 1 into x power 0, and the power represents which term is that. Okay, plus sorry, minus, alternate plus minus sign, minus 2x power 1 plus 3x power 2 plus 4x power 3, so on. Okay, so minus plus, it will be a minus. Minus. This is the question that is given to us. Here we now know the standard generating function of the GP series is 1 by 1 minus x. This is the equation of the terms in sum of infinite terms of GP, that is 1 plus x square plus x cube plus so on. Now, how do we find the closed form of this sequence? Okay, we will observe the pattern. So to get the closed form of any general sequence from this standard uh, standard generating function of the sum of infinite terms of a GP is that the possible operations can be variable multiplication or differentiation or addition of two standard generating functions, subtraction of two generating functions in order to produce this. So one thing we can observe is that if we have 2 in the power of x, okay, this term, let's observe this term. How can we obtain this term? If we had in x's power 2 and we differentiate this term, we will get 2x power 1. And if we substitute x by minus x, this x power odd will make the minus 1. If we substitute x by minus x power 1, so that will be minus x itself. So all the even terms will get a minus sign. So what we will do is, what we will do is, we will multiply this whole series by x to get x power 2, in this place x power 3, and then differentiate to get that power in the coefficient as the coefficient and substitute x by minus x. Okay, so let's go step by step. First step, we will multiply both sides of 1 with x. Hope you understood why we are multiplying with x, because in the 0th term, right, the first term x power 0 is there, and what we need, one into, from the second term we observed that 2 is multiplied in the coefficient, so that means we have to get x power 2, and here x power 1 is there, so multiply by x to make it x power 2. So x by 1 minus x would be x plus x square plus x cube plus x to power 4 plus so on. Okay, now what we will do in the second step, we will differentiate both the sides of equation 2. Differentiate, DIFF means differentiate equation 2. So what we will get is derivative of x by, wait, uh, yeah, differentiate equation 2. So what we get is derivative of uh, x by 1 minus x, which is equal to x power 0, right? This would be 1 into x power 0, 2 into x power 1, 3 into x power 2, 4 into x power 3 plus so on. We are using derivative of x ki power n is nothing but n into x ki power n minus 1, that formula. Okay. So now what is the derivative of x by 1 minus x? We will use u into v form, where u is your x and v is your 1 by 1 minus x. Okay. So we will go to another page. So derivative of x is 1 into 1 by 1 minus x plus derivative of 1 by 1 minus x is 1 by 1 minus x, the whole square, 1 minus x the whole square into x will be multiplied as it is equals to 1 into x power 0 plus 2 into x power 1 plus 3 into x power 2 plus 4 into x power 3 plus so on. We are again using here the formula derivative of x power n with respect to x is n times x power n minus 1. That formula only we have used. Okay. Then what we are getting, we have to multiply this, we have to make the denominator same, 1 minus x whole square. So we will multiply this side by 1 minus x plus x by 1 minus x, wait, 1 minus x the whole square is equal to this, and this term is cancelled. So we'll get 1 into x power 0 plus 2 into x power 1 plus 3 into x power 2 plus so on. Okay. Now we need alternating plus minus sign. Okay. So what we will do is in every odd power we need minus 1. To substitute, this is equation number 3. Substitute x by minus x. Okay, so this would be 1 by 1 plus x the whole square is equals to 1 x ki power 0. Okay, plus, okay, this is minus x power 1, that is minus, that would be minus 2x plus 3x square minus 4x cube plus 5x ki power 4 plus so on. Okay, so we got our answer. The closed form of the generating function is 1 by 1 plus x square. Let's see the options. It's option number 2. Okay, so I will recap once again how to think. Whenever you get a series is given to you in the question, and you have to write the what generating function produces that sequence. What you do is you first try to think how you can convert this standard generating sequence of the sum of infinite terms of a GP1 plus x square plus x cube plus so on. And the possible operations you can do on this is multiply x power something to this, okay, or you can differentiate ddx of this, or you can substitute something. Substitute x by some variable, okay, to get, or it might be addition or subtraction, add two known known generating functions, okay, or a combination of these operations, okay. This is how your thinking approach should be. So 1, 2, 3, 4. The combination of these four operations will produce the generating function for any sequence given in the question. You have to be careful and observe. So hope you like this video. Please share it with your friends and subscribe to my channel. And keep thinking and relating questions to the real world. And happy learning. Bye bye.